Now let's talk some more about variables. We start the declaration of a variable from the keyword var, followed by the name of the variable, a colon, and the type of the variable. A colon in Swift usually means that the expression on the left is of the type specified after the colon. For instance, a declaration of the variable that stores temperature in centigrade could look like this: var Celsius float. In this case, float represents a type of floating point data that represents real numbers. The basic data types in Swift include strings, which represent a line of characters, in other words, text, characters, which represent a single character. In Swift, it's a single Unicode character. In other, especially older languages, it was a single ASCII character. Int, the simplest number type, which represents integer numbers. Float, the number type we mentioned in the previous example, and it represents real numbers. Double, a much more accurate number type, also intended for working with real numbers. Bool, a logical type that represents logical values. 1 that is true or t, and O that is false or nil. Apart from variables, we can also define constants in Swift. A declaration of a constant is very similar to a variable declaration. We start it from the let keyword, followed by its name, a colon, its type, and, after an equal sign, its value. For instance, a declaration of the pi constant could look like this: let pi colon double equal sign value pi. We'll return to the pi in a while to demonstrate another interesting property of Swift. We should use constants whenever we know that a given value mustn't change once it's assigned. If we accidentally try to change the value of a constant, the compiler will warn us to spare us some errors which could be hard to detect. It will also optimize our code. The right labeling of values will also make our code easier to read and make the intentions of the programmer clear. Such a code is also safer, which is particularly important in the case of multi-thread programs. Now let's look at several additional examples of declarations of variables and constants in Swift. Here we can see the following declarations: a constant, that is the capital of Poland; a variable, that is the population of Poland in thousands; and a logical variable, that is an even number, and again the pi constant. All the values are initialized with the value present on the right of the equal sign. The most interesting example is probably the declaration of the pi constant. In Swift, we can use almost any Unicode character in the variable name. You can even use emoticons, so the notation we presented here is by all means correct. In many cases, there is no need to specify the variable type. Based on the declared default value, Swift is usually able to correctly determine it on its own. This is called type inference. We can simplify our declarations as illustrated in the slide. Now let's move on to character variables and character strings. We already know how to declare character type variables and constants. Now let's see how to use them. Adding strings to each other and mixing strings with characters is very simple in Swift. For this purpose, we need to use the addition operator plus. We can also iterate over any string of characters by using a simple for-in loop. We'll deal with loops in detail later in the course. In the next example, we see a bit more complex formatting of a character string. It makes it possible to combine the values of variables and literal characters into a single coherent whole. If you programmed earlier in Objective-C, you'll probably be glad that in operations on characters, it's very easy to use the methods offered by the NSString class. All we need to do is import the foundation library, and all the NSString methods are available. In our example, we show how to use the pathComponents method. If we want to use a string constant or variable in Swift, we can do it in a very simple way by, in a way, reversing the assignment. NSString first equals path elements brackets 0 brackets. In software, we often need to use groups of objects related to one another or sets of related values. In such cases, what comes in handy are data sets, particularly arrays and dictionaries. For instance, declarations and definitions of a 4-element array that contain character strings representing the names of galaxies would look like this. In order to read the value of an array element, we need to refer to the specific array element through its index, where the index is the name of the element we're interested in. We have to bear in mind that, like in C or Objective-C, arrays are indexed from 0. So in order to read the value of the first array element, we have to use the 0 index. In this case, expanding the array with new elements and values boils down to adding the relevant character string. It's interesting that when adding a new element, we don't have to limit it to a single value. There is nothing to prevent you from adding more of them using a single command. In our case, we can see an array with 4 galaxy names. We can set the number of elements in an array by reading its count property. We can see that its value is displayed with the print-in statement. We now add a new element to our array, the Leo 1 galaxy, and then add 2 other ones, that is Leo 2 and GR8. After all these operations, our array stores 7 elements, which can be seen by calling the print-in statement again. It's also very simple to change the value of an array element. As in the case of reading, changing values is also about access via the right index to the array element which we want to modify. Just like in the previous example, when adding new elements, in the case of updating values, we can also change several of them simultaneously. Suppose we wanted to relate each galaxy to its distance from the Earth. The dictionary would come in handy. Dictionaries are characterized by the fact that each of their elements is represented by the key, a value pair. In our example, these are the galaxy name and its distance from the Earth in millions of light years, respectively. Operations on dictionary elements are very simple, as it was with arrays. Adding a new key value pair boils down to assigning a value to the key that doesn't exist yet in the dictionary. Changing an existing value into another means assigning it to a key that already exists. Now we'll see how we can browse all the dictionary elements. Notice how the for-in loop refers to the key and the element values of our constant. A pair of variables in brackets is called tuples, which we'll discuss later. The text highlighted in green is a commentary, which can be any text and has no influence on the operation of the program. Here I used it to show the result of the operation of the loop. Similarly to character strings, arrays and Swift dictionaries can be easily used in Objective-C. Those of you who are Objective-C programmers surely know the NS-array and NS-dictionary classes. There are two basic differences between Swift objects and the Objective-C classes I've just mentioned. The first one is that they can work with any type of data. They're not limited to objects, as was the case in Objective-C. The other difference is that they store values of only one type. This means, for instance, that we cannot add an object or a number value to a string array. Let's consider what would happen if we try to read a value of an unidentified key from the dictionary. It isn't always clear which value could represent something that doesn't actually exist. Should it be a zero, a negative value, null, or nil? To correctly handle such a scenario, Swift offers special constants, or variables that can assume nil values, that is, non-existent ones. In Apple terminology, they are called optionals. Such values are declared using a question mark placed after the name of the data type, that is, a constant or a variable. In our case, we can see a constant value stated this way that represents the distance to the Leo 2 galaxy. On the right, we see that the constant assumes an unspecified value, nil. In order to correctly read the value from an optional, we have to use the exclamation point operator. Before gaining access to the data stored in the optional, we also need to remember to always check whether it's actually a nil value. In our example, we can see a correct reading of the optional value, the distance to the Sagittarius galaxy. It's a lot to write, but fortunately, the if condition presented in the example can be simplified by checking the negative condition exclamation point equal sign handled in the first example, in the else block. We can simplify it even more by moving the variable declaration and assigning the value to it directly in the if construction, as illustrated in the presentation. Let's repeat what we should remember from this lesson. Before reading and assigning values to a constant or variable, we must always check whether the optional value isn't a nil value. If we don't do this, any attempt to assign such a non-existing value will end up with an error. Now let's move on to loops. A while true loop is one of the basic loops used in programming languages. It executes statements placed between brackets for as long as the input condition of the loop is fulfilled. For instance, calculating the n factorial value using a while loop can be implemented in the following manner. In the example, we first initialize the variables n with the value 5 and factorial n with the value 1. Then, in a while loop, we execute the operation factorial n asterisk n for as long as the value of the n variable is greater than 0. Additionally, each loop execution decreases the value of n by 1. We can also write it in a bit more concise way. The next loop, very important in Swift, is the for loop. Similarly to a while loop, it allows a group of statements present in the brackets to be executed multiple times. The main difference between while and for loops is that in the case of the latter, most often we know the number of loop repetitions because it's based on a counter. A while loop, by contrast, is executed for as long as the loop condition is fulfilled, that is, it assumes the true value. In the Swift language, a for loop is present in two variants. The traditional variant is based on a controlling variable, or the counter we mentioned, whose value is modified with each loop repetition. The other version is for in, which is most often used to iterate over collection values. In the case of a traditional for loop, the initializing expression is executed only once, and then the continuation condition is checked. If it's fulfilled, that is, it assumes the value true, the commands in brackets are executed. The loop control variable, in other words, the counter, is then modified and the condition is checked once again. If the loop condition isn't fulfilled, that is, it assumes the false value, the loop execution is stopped. Otherwise, the contents of the loop are executed again. In our case, we see the code that calculates the value of the n factorial expression based on a for loop. A moment ago, we saw the same algorithm implemented using a while loop. We saw a for in action when discussing operations on character strings. As a reminder, the code we've shown iterates, goes through all the values of the educativo string, and displays each string character in a new line. We saw another example of using a for in loop when discussing dictionaries. The code fragment we've shown demonstrates how to browse all the elements of a collection, in this case, a dictionary. In our case, it's a dictionary that stores the name of the galaxy and the distance to it.